Gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute, and its coarseness is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? So using the illustration given, let us label the diameter of the cone, the base diameter of the cone by D. So we use D to represent the diameter or the base diameter of the conical pile. And then let us use H so to represent the height of the conical pile. Now we are given the rate of 30 cubic feet per minute, which indicates that this is a change in volume with respect to time. So let us just use V for the volume of the conical pile and represent by dV over dt the given rate, and that is 30 cubic feet per minute. Now, this rate is going to be positive because gravel is being dumped from the conveyor belt, which means the amount of gravel increases with time. So, dV over dt is positive. Now, we are required to look for how fast the height of the pile is increasing. So, that would mean dH over dt when h is 10 feet. Okay, so now we set up the equation that would solve this problem. Since it involves volume of a cone, we will be using the formula for volume of a cone, and that is 1/3 V, or volume is 1/3 pi r squared times height. Okay, now we observe that in this equation, so V is equal to 1/3 pi r squared times h. We notice that we have three variables. We have volume, radius, and height. However, we are given only the rate of change in volume, that is dV over dt. We are actually required to look for the rate of change in the height with respect to time, that's dH over dt. And the problem is we do not know what dr over dt is. So to solve this problem, we are going to write the radius in terms of the height. Where are we going to get the relationship between the radius and the height? We are going to use the given in the problem, that is the diameter was said to be equal to the height throughout time. So D is equal to H as given in the problem. Now, since the diameter is twice the radius, and since the diameter will always be equal to the height, so we have H is equal to 2R, and that R is equal to H over 2. So we are going to replace R in the formula for volume with H over 2. So we have V is equal to 1/3 pi. We replace R by H over 2. You have squared and then H. And then simplifying, we have 1/3 pi h squared over 4 times h. And finally, we write this as 1 over 12 times pi h cubed. So this is the formula or the working formula that we are going to use in solving this problem. So next step will be to differentiate this implicitly with respect to time. So we have dv over dt is equal to, we copy 1 over 12 pi and then get the derivative of h cubed, and that is 3h squared dh over dt. So we cancel 3 because we cancel 3. dv over dt now will be 3 over 12 will be 1 over 4, and then we have pi h squared dh over dt. So the problem requires us to look for dH over dt. So we divide everything by 1/4 pi h squared, both sides of the equation. We have dv over dt is equal to is divided by 1/4 pi h squared, and this is equal to dH over dt. And then further we rewrite this as, so we get the reciprocal of 1/4. That's why the equation becomes 4 times dv over dt all over pi h squared. So this will now allow us to find the value of the rate of change in the height with respect to time at the given height, which is 10 feet. So at h equals 10 feet, we substitute to our resulting equation. So 4 times dv over dt was given to be 30 cubic feet per minute. And then you have over pi. So h is 10. Then we square it. This is equal to dH over dt. So computing this gives us, so let's continue on this side. So we have 4 times 30 divided by the quantity pi times 100, which is 10 squared. So we get 6 over 5 pi, which is approximately 0.38. The unit is in feet per minute or foot per minute. So therefore, dH over dt is 0.38 foot per minute. And let me write the interpretation here. The height of the conical pile increases by 0.38 feet for every minute at the instance when h, or when the height is 10 feet. So that solves this given problem.